Okay, today I'm going to spend the next 30 minutes and lecture on thyroid in relationship to iodine, selenium, arsenic, and mercury, and how those are all linked together, not only for the importance of thyroid formation and conversion of T4 into T3, but also how it's important with regard to breast health as well as heart health. So iodine deficiency is very important for the fetus. Without adequate levels of iodine, you can have miscarriages, stillbirth, congenital abnormalities, cretinism, brain damage, etc. It's also important for the neonate. You can have, without adequate levels of iodine, you could have endemic cretinism, neonatal goiter, hypothyroidism, and endemic mental retardation, and that's something that could be prevented with adequate levels of iodine in the diet. And even in the child or adolescent, you can have goiter, clinical hypothyroidism. School performance is impaired. There's lower IQs by as much as 13 to 15 points lower in those individuals who have low thyroid as a result of low iodine. Is retarded growth, hearing, and speech problems. And in the adult, inadequate iodine can result in goiter, apathy, overt hypothyroidism, which is associated with low T4 and high TSH, suboptimal brain function, sluggish thinking, which is something you don't want to go to work with every day, low capacity for initiative and decision making, can result in spontaneous hyperthyroidism as well as iodine-induced hyperthyroidism. So people living in a low iodine environment that then can develop autonomous thyroid nodules that then, when exposed to higher levels of iodine, maybe by supplementation, can actually develop hyperthyroidism. So what we did is, with that interest in iodine and the thyroid as well as breast cancer, we wanted to develop a urine iodine test. So in order to test a lot of people in a very simple way, we developed what we called a dried urine iodine test, which basically is a filter strip. You either urinate directly on the strip, or you can urinate in a cup, as you see here, and dip it in this filter, and then dry it, and then ship it in a dried form. So it allows for the urine to be shipped in a dried form. And you can see here in this diagram that the correlation with dry versus wet iodine is very, very good. This is done by an ICP mass spec methodology. This is a very complicated slide, but the basics of this slide are that iodine is, this is in the thyroid gland, iodine is taken up by the thyroid gland by the NIS, and that's the symporter. It's taken up, and then the iodine is incorporated into thyroglobulin. So basically what's happening is thyroglobulin is binding to iodine. The iodine is being activated by thyroid peroxidase and hydrogen peroxide. And the point that I want to make here, it's a very complex slide, but the primary point that I want to make here is that it's a very hot reaction. That the process of making thyroid hormone in the thyroid gland requires an oxidant, hydrogen peroxide. In order for the thyroid gland to protect itself, it has to have glutathione peroxidase. That is a selenium-dependent enzyme. So here we're getting to not only iodine but also selenium. So selenium is critical for adequate formation of thyroid hormone in the thyroid gland. If there's too much iodine present and not enough selenium, it can result in goiters in the thyroid gland. So essential that selenium be present in adequate amounts. So the thyroid gland is dependent on selenium for thyroid hormone synthesis as well as it is iodine. But also extrathyroidal tissues are dependent on selenium for the synthesis of the conversion of T4 into T3. These are thyroid deiodinases. There basically are three types of thyroid deiodinases, what's called D1, D2, and D3. D1 converts T4 into T3, D2, and it's present in the plasma membrane of the cells. As you can see here, D3 on the top diagram. D3 and D1 are more present on the outer surface